All right, hello, welcome to the feedback quiz solution, chapter 5 for normal curves, univariate data. All right, so the first question, why do we use z-scores? Well, it normalizes the data. So when you take your standard deviation and you divide your differences by the standard deviation, you get that z-score, right? So, but by dividing by the standard deviation, it removes the units from the whatever it is you're working with, the standard deviation and the standard deviation has a particular unit on it which will match your mean and your value unit. So when you divide it, it cancels it off. So the z-score is unitless and it's kind of what we call normalized. So it doesn't matter what group it is, whether it's the 100-meter dash or whether you're throwing the shot put or whatever it is, you can compare things now, even though they're different events and different units. Number 2, a drink company decided to increase the size of their bottles. So this is talking about what happens to center and spread when you add stuff to data points. So the center in this case will change from 200 to 250. You just think about the whole set of data just moving up. But they're using the same machine, and there's no reason to believe the standard deviation would change at all. So that's just going to stay 4, right? The centers change with the addition and subtraction, but spread does not. Number 3, on a normalized set of data, 0 is your center because that becomes that's where the mean would be. So you're like, when you do the formula for z-score, you're taking the mean minus the mean, which you're going to get 0, right? Standard deviation is always 1. So this is all in terms of z-scores now, right? So -1, -2, +1, +2, but center 0, 1. And number 4, type of data that would be normal in shape. Height usually is, weight, body mass index, speeds of certain things. There's all kinds of them, but some are tricky. Some you think might be, but really are not. Like if you took the income of a bunch of people randomly, you would find that there's a very few people who make a lot of money and a whole bunch of people who don't. So those few people who make a lot of money kind of skew the data towards the higher numbers. And if you have skewed data, it's not normal in shape. So you have to be careful. Not everything is normal. When we say normal, we really mean normal. It can't be skewed left or skewed right or bimodal or anything like that. So like hair length would also not work because there's a whole bunch of people like me who don't have very much hair. So you'd have a whole bunch of zeros in your data or little ones or halves or something, and it would really make your data look kind of weird and skewed. It wouldn't be normal. Number 5, on a normal model, what percent of data do we expect to be larger than one standard deviation? So if you go 1 up and 1 down, our empirical rule tells us that 68% is in the middle. So that leaves 16% in each tail. So that means that 16% of your data would be larger than one standard deviation. That's it.